In my recent video on binary, I explained how two-state transistors are used to represent binary numbers composing data. In this video, I will explain a different way that binary data is stored, which is on a spinning disk drive. Now, if you haven't seen my video on binary, or if you don't exactly know how binary works, it might help to check that video out after this one to give you some context. So we know that computer data is all stored in binary, something that can have two states, which is interpreted as a 1 or a 0. How does a spinning disk achieve this, and what advantages does a spinning disk have over the microtransistor method? The answer to how is essentially just with magnets. The spinning disk in your hard drive contains what is known as ferromagnetic material. Put simply, that means it can be magnetically charged. Your hard drive is divided into billions of tiny little magnetic regions. Each magnetic region can have its polarity changed to be positive or negative. Therefore, a single region is used to represent a single digit of binary. Typically, a positive charge represents a 1, while a negative charge represents a 0. The disk is placed on a central spindle. The spindle spins around, causing the disk to spin around. Meanwhile, an actuator arm is placed on top of the disk, not even a millimeter away from it. This arm has the ability to send very subtle magnetic charges to the disk and the ability to interpret the ones that are already there. This is known as reading and writing information. When you install a program or download a picture to your computer's hard drive, the actuator arm leaves a long pattern of charges along the spinning disk. That's writing information. When you run said program or load said picture, the actuator goes back to where it put that pattern of magnetic charges, interprets it, and sends it back to your CPU or RAM or wherever it's needed for quick access. This is the reading process. Before moving on, I'd like to make a side note here. It's worth mentioning just a few things. Modern hard drives have multiple spinning disks, each with their own actuator arm. Additionally, a disk can have information stored on either side of it, so each disk has an actuator arm for both sides. Lastly, many modern hard drives have a different part of the actuator arm read and write, allowing things to be loaded from and onto the drive at the same time. Now we know how data is stored on and read from a spinning disk. But with all of the files and programs stored on your hard drive, how does it know where physically on your hard drive it's stored that pattern of magnetic charges? The hard drive has two methods of doing this. One is with what is known as a cache, the other is with what is known as a file allocation table. First, let's talk about the file allocation table. The disk of a hard drive is divided into several different organizational areas. We mentioned regions are the small tiny parts that each represent a digit of binary. Now, tracks are essentially concentric rings around the drive which the regions can be stored on. Each track is divided into segments called sectors, and multiple sectors are grouped into what's called a cluster. Whenever you install a program or store data on a disk, the write head on the actuator arm stores the data there and then immediately afterwards writes a smaller, easier to access piece of data, letting it know generally which track and cluster it stored the data on. Later, when you go to load that data back up, the reader head first checks the file allocation table to figure out where to go, and then goes there to find the specific piece of data you're looking for and read it. Now let's talk about the cache. This works very similarly to the file allocation table, but with a significantly more precise map to where that data was stored, therefore resulting in significantly faster loading times. A cache can be stored on the hard drive itself, in your RAM, or even in the CPU. Caches are made when your computer identifies information that needs to be accessed very quickly and very frequently, such as if you imported a video file into a video editing program or a photo into Photoshop. The data is still stored on your hard drive, but because your CPU has a cache knowing exactly where on the hard drive it is, it can be accessed and loaded into RAM very quickly. So that pretty much wraps up the fundamentals of how a hard drive stores data. Now let's address the question of why. Why use something that is essentially a hyper-advanced record player when we have solid-state technology? All the other binary data in your computer is stored using microtransistors, small switches that don't move and can be accessed much faster without having to wait for a spinning disk to finish a revolution. Well, what disk drives lack in speed, they make up for in space. As small as microtransistors are, they don't compare to the magnetically charged regions on a disk drive. And while microtransistors get smaller every year, so do these magnetic regions. Currently, the average solid-state hard drives have about a 500 gigabyte capacity. For the same price, you can get a spinning disk hard drive that will have about a 3,000 gigabyte capacity. The optimal setup for a modern computer is to have a solid-state drive for your operating system and programs to be installed on, and then have a large capacity spinning disk drive to have all the data that those programs reference stored on. I personally have a 500 gigabyte solid-state drive that excels in speed, which I run my operating system and my programs from, and 3 spinning disk hard drives, each with about a 3,000 gig capacity, which I store all my data on. So that's the basics of how hard drives work. Like with anything related to computers, there is an enormous wealth of information to learn about this, so I encourage you to do so. If you'd like to see more videos explaining hard drives and data storage, the like button is a quick and easy way to let me know this video is of interest, and subscribing or leaving feedback is always appreciated.